So now we can detect a line on a surface. Okay, so this is great. So let's do this. Let's create a line following program that will allow our BOE-Bot to actually follow a line that's on the ground. Okay, and so we're going to do this with a single QTI sensor, so what you already have on there, and we're just going to do this simple left-right algorithm. So let's think about this. How could you follow a line? Okay, well, we have the ability to detect whether it's white or black. So there's this just most basic way to do this is to try to detect the transition between the white and the black. So when you think about putting a tape on the ground, you're not actually following the line itself. What you're following is the edge of the line, this white-black contrast. And so all you do is you create this program that you're going to move forward left or forward right, and if you're on the white part, we'll have it veer to the left, so light veer left, and then as it goes into the dark part of the tape, you'll veer back right. And so you essentially just go left, right, left, right, left, right, left, right along this transition. And there's a lot of variables here. It's like how sharp do you turn left and right? There's a variable for that. How long do you do it before you sense and stuff like that. And so as you play around with this, you'll see all these different variables, and you'll be able to make a very a more sophisticated, smooth-looking movement, or it'll be real jaggedy going back and forth. But it's just a really cool way to get started. Okay, so let's do it. All right, so let me pull up our Arduino sketch that we have, and this is our I renamed this QTI Activity 1, QTI testing, and what I'm going to do is I'm going to take this and I'm going to add in the locomotion component of it. So let's create a new sketch. So I'm going to do a save as, and instead of calling it let's see here, instead of calling it QTI 1, I'm going to call it QTI Activity 2, and let's do line following. Okay, so I'll go line following. Okay, all right, and so now we got to remember how to do our locomotion part. So we're going to add into here a little bit of servo code. So we got to pound include our servo, and at this point you're probably copying and pasting a lot of your prior code, but I'll just type it in just to just so that we can walk through it. So I do my servo right and left instances, and then I come down here. I'm going to do testing line sensor or line follower, and that'll tell me the program's running. We're going to play a little tone here. You know what I'm going to do? I'm actually going to play a little startup tune. So what I want to do is I'm going to add something kind of neat in here. I'm just going to go let's go start off with a 500 kilohertz or 500 hertz, and then we'll do a 1500, and then we'll do a 1000, and then we'll do 2000. Okay, just to play four little fellas there. All right, life is good. And now we're still in our setup. We have to set up our motors. Okay, so set up motors. And remember, we need to do a servo left dot attach, and mine are on pin 11. My left is on pin 11. My right is on 12. And now I'm going to do, remember, now we have these subroutines from before, so we got to put them back in here. I'm going to call a halt function, and then I'm going to delay for 1000. Okay, now we need to copy and paste halt in there, so let's think about that. All right, so now when I come into my loop, what I'm going to do is I'm going to go grab my functions from before, from our previous work, and I'll go ahead and copy them from a prior project, and I'm going to come down after the loop part. So here's our loop, and I'm going to pop these functions, and I'm building up this huge kind of library of functions that sit down here. And so now I have halt. Okay, so great. So now I do this halt, and now it's time to come down and take a look at how we're going to do this. So I set up the motors, and now I'm in my loop. I still want to check on what's going on with the line. So the first thing I'm going to do is I'm going to go ahead and I'm going to output the line. I'm going to turn on pin 2 as an output. I'm going to write it high for 1 millisecond, and then I'm going to read. I'm going to wait, then I'm going to wait for a millisecond, and then I'm going to read it. Okay, so now I have this right here, sensor 1, and it's either going to be a 1 or a 0. Okay, so that's what I'm going to basically make my decision on. Okay, so think about this. All we really need to do here is the following. I am going to delete that print statement, and here is where I'm going to do my motion. And I'm going to define 2 new functions, and I'm going to call them Veer Left and Veer Right. So let's type them in, and then we'll see what the code looks like. If I have sensor 1 equal to a 0, that means I'm on the light part of the surface. Okay, and what I want to do is I want to turn left, but I don't want to turn left like a 90-degree turn. I want to go forward left, and so I'm going to call this function Veer Left, and it is going to be Veer Left, and I'm going to pass in a time. Okay, so how many milliseconds I'm actually going to veer. So this is going to be 5 milliseconds. Okay, and then if sensor 1 is not a 0, okay, that means it's a 1. That means I'm on the black side of the tape. And so that means I'm going to veer right. So all I do is I say else veer right for 5 milliseconds. And that's it. Okay, so then I just do this, and I put this in the curly brackets, and there's my entire program. Okay, so check this out. I'm in a loop, and all I'm going to do is I'm going to come through the loop. I'm going to read the sensor and determine whether I'm on black or white, and I store this in our sensor 1 variable. And then I just do this simple if-then statement where I say if I'm on the light part, go left a little bit, and if I'm on the right, I'm on the black, go right. And I've created this little function that I'm going to pass in milliseconds. Okay, so the only part left here is we need to go down and we need to create our function for Veer Left and Veer Right, and let's do that really quick. Okay, so here's what I'm going to do. I'm going to come down here and I'm going to start a new function. I'm going to call it void Veer Left, and I'm passing in time as an integer. So I have to do it like that. It's void means it's not going to return anything. And now here I go. And now what I'm going to do here is I'm just going to put in some servo statements in order to move this forward and to the left. And we have all this stuff. So let's go servo left, and then I'm going to do right microseconds, and I'm going to do something above 1500, but I want it to be moving forward, but I want the left wheel, since I'm trying to go left, what I want to do here is I want to have the right wheel moving forward a little bit stronger than, or a little bit faster than the left wheel. Okay, and let me write it like this. I'm going to do 1500, which represents stopping, and then what I'm going to do is I'm going to actually put a plus or minus on here. So I know when I'm moving forward, I'm always going to be above 1500, and so I'm going to put in a number right here that's going to represent kind of how strong I'm telling the motor to go above 1500. And I'm doing this intentionally because I want to start thinking about what I'm adding or subtracting to this 1500 to get it to go. Now my right one, what I'm going to do is I'm going to say servo right, and I want this one to be 1500 minus some number. Okay, so now let's think about this. I want to think about, I'm trying to veer left. I want to move forward but go left. So that means I want my left servo to be moving forward, but I want my right servo to be moving forward faster. Okay, so check this out. What if I did a number right here like 75 and 25? And the reason that I put this plus and minus here was I wanted to be able to really, obviously see which number is bigger. So when I look at this, it's like, okay, 15 minus 75, yeah, that's 1425, and this one up here is 1525. But by putting it as a plus and a minus, I was able to notice that I'm going to basically make the servo right move faster than servo left. And this will become very interesting later when you try to think about, passing parameters in and dynamically changing how strong you veer left or steer right. But I'm just going to type it in like that, and then we'll just rock and roll. Okay, so now let's do our other one, which is veer right. And when I'm veering right, I want my left servo to be moving a little bit faster. So let's do that as a 75, and this is a 25. Okay, so now I've got these in here, and the only other thing that we were missing is we need to have the time. So what I'm going to do is, after I set these motors up to do this, I'm going to go ahead and do a delay, and I put time, and that's my variable that I passed into both of these. So I go ahead and copy, and I paste that into both. Okay, so I've got these little babies. And let's go ahead and save this, and we will download it. And let me bring up, okay, so I have a typo. I type attached up there. Good thing. All right, so I go ahead and do that, and I'm going to go ahead and say tools, port COM3. Switch ports on me when I unplugged. Okay, so it's off and running, and I've got my guy right here, and I have my program almost ready. So testing line follower. Oh, the tone isn't playing here, so I forgot to put delay 500. Okay, so delay 500. Okay, you always got to remember this tone. You turn it on and tell it to do this, but it sets up the port, but then it moves immediately to the next instruction. So they'll override each other and only play the last tone unless you delay. Okay, so now life is good. Okay, so now here I go. I've got my course set up. I've got some blocks back here in order to keep this from running off of the table. Okay, now you hear the tone play there, and I've got it powered up by battery. I've got it in position 1, so it didn't take off. I'm going to go ahead and disconnect the cable, and now I'm going to hit reset and put it onto pin 2. And here's what you're going to go. It's going to go jig back and forth. So there it goes, and look at what it's doing. It is basically going back and forth, left, right, left, right, left, right, left, right, right. It looks horrible, but it is following the line, and I'll put my hand over here to make sure it doesn't. Okay, so here, look at it. It's going. Is it going to make the turn? It is making the turn. It's making the left-hand turn. Here it comes. And now here's the big test. Is it going to make the right-hand turn? And it did it. Okay. Now what's it going to do when it comes off of this? What would it do if it doesn't see a line? Well, it's on light. It'll just sit there and go in a circle. So it's just going left, right? That's what it looks like if it's not on a line. So all it's doing is light left, dark right. Okay? So it's simple. I mean, it's a really simple algorithm, and it doesn't look good. But you know what you can do is you can mess with a bunch of different variables, such as, so here, watch this. It's going to turn left, then it'll see the line. And if it comes off of the line, like if you have too sharp of a turn, what'll happen is it'll come off of the line and it won't be able to recover. So I can actually show you that. Let's say that I'm going to try to turn right, but I couldn't quite get it. Okay, so now it's going to take this super sharp right-hand turn, and it won't be able to get it, so it'll come like way off. Okay, so here it comes. And look, it came off of the line because it was too sharp, saw a line, and now it's all over the place. Okay. So anyway, pretty cool. So what do you do in order to get this to be more, exact? Well, it's all about these little variables. You think about veer left and veer right. It's how long are you going to steer left and steer right as you make those decisions about this right here. How long are you going to do this before you stop moving and then check where you are again? And then the other variable is going to be down here in your veer left and rear right subroutines. It's how strong of a turn are you taking. And this is, I call it simple because we're doing it with one sensor, and we're not dynamically changing, like we're not saying turn left, oh we're not there yet, turn left stronger, turn left stronger, turn left stronger. We're not dynamically changing the turn, we just have it fixed. And so these are the variables that you can mess with. But we did it. We did this line follower, and it's pretty awesome.